Today I'll be exploring the various intricacies of a popular emerging technology called deep learning sequence-to-sequence synthesis neural network modeling. It features an autoregressive wavenet-based vocoder network generating time-domain waveform samples, which are what you are listening to at this very moment.
This particular program was developed by the grad student Corentin Jemine. He is one of the few people that have taken the time to create a relatively user-friendly interpretation of the scientific paper, Transfer Learning from Speaker Verification to Multispeaker Text-to-Speech Synthesis, which was published in NeurIPS in 2018. There are other, more effective software and models, but this particular software has been gaining popularity due in no small part to the apparent ease of use and intuitive interface. Let's see a quick example of the working product.
This is a voice cloning toolbox. It allows you to clone the voice of someone from only 5 seconds of audio and to synthesize speech with that same voice.
Really was impressed with them. I thought that they did so well, and it was a tough final, I think.
There's a way to measure the acute emotional intelligence that has never gone out of style.
After heading over to the GitHub page, you will notice the apparent lack of setup instructions. You will also find a link in the README that directs to a website called Poor Documentation with an Improved Setup Guide. Very ironic. We will be using this partially for this guide. Once everything is said and done, you may have it working. If you are like me, however, it will still be broken. Today, I will walk you through the process I use to fix these issues. We will follow the usual instructions, and then I will show you how to solve the errors that appears. Heads up, this software will only work with media cards, so the limitations with CUDA, so apologies to all you AMD fans out there.
First, we will need to download Python 3.7. Instead of dealing with the hassle of configuring everything ourselves, we're going to use a scientific software package called Anaconda. Anaconda comes bundled with a lot of different things, some that we need and some that we don't. Anaconda is a lighter alternative, but for now I recommend the full Anaconda installation for our purposes.
Now you will want to download 3 other things from the GitHub page, which I've also linked in the description of this video. Download the pre-trained models, the zip file of the repository, or clone it if you know how to use GitHub. As we wait for the downloads to finish, we'll hop over to the Anaconda Setup.
Open the Anaconda PowerShell terminal window. First, create a new Python environment. Environments are places to store different installation configurations for Python packages. For example, one environment might be running Python 3.6 while another is running Python 2.7. Create a new environment using the command conda create and voice clone Python 3.7. Python version 3.76 will be automatically installed. This is version of Python working in the poorly documented guide and the version that I stuck with. Once the new environment is built, switch to it if it is not already the active environment by using the command conda activate voice clone. Now we install the required packages. First in the list is PyTorch version 10. In your conda terminal window, use the command conda install PyTorch Torch Vision CUDA toolkit equals 10.0 C PyTorch to install it. Once complete, you need to navigate to the conda install folder and find the Python installation folder in the voice clone environment. It will be located at the default installation location on screen. Find cuDNN 64.7 and either rename it to old or delete it.
Now unzip the folder from the CorentinJ voice cloning repo on GitHub. In the folder you will see a file called Requirements.txt. Open the file in any text editor. Notepad will work fine. Change the requirements to the following. In future releases, these requirements will be deprecated, and you should use the ones in the current version of the repo. But for now, this is what I use to get to work on my machine. Now go back to the Anaconda terminal, use the command pip install r requirements.txt.
A quick note for you. Make sure that you are in the directory of the unzipped repo folder that you downloaded from GitHub. Use the command cd and then drag the folder into the terminal window and execute it to navigate to the specified directory.
Once complete, use the command conda install c conda forge tensorflow to install TensorFlow 14, which was the only version I could get working. You can try 1.15 if you like, but I wasn't able to get it to work on my machine. Then, download NVIDIA CUDA 10 from their website.
After running the executable, you can deselect all the optional components such as driver components, other components, documentation, visual, studio integration, samples, and end-site compute. If you plan on developing this software more yourself, you'll know which ones you want to include. Now, not to be confused with CUDA, CoDNN is the deep neural network library for CUDA. Download the CorentinJ 10 zip folder and unzip it. Copy the directories directly into your CUDA 10 install folder. The default installation, located at the following directory. Once this is completed, you can download and install Visual Studio Community. It has the necessary developer packages that we will need, and this is the easiest way to install them. When installing, you can deselect everything except MSV, C++ build tools, and Windows 10 SDK. Now that your system is configured, you will want to launch the Toolbox GUI. To do this, switch back to the PowerShell prompt and make sure you are still in the voice cloning directory. Once there, use the command python demo toolbox.py to run the program. If you followed all the steps correctly, it should launch without an error. If you have an error, double-check to make sure you followed all the steps correctly. Or try going through the poorly documented guide by itself. Or you can go through GitHub issues in the repo to troubleshoot your specific problem. Now we need to add our own data set. Download clips that are 5 to 10 seconds long from the voice you want to clone. Create a new folder in the CorentinJ directory and call it user audio. There you can copy existing datasets like LibreSpeech or make your own folder called whatever you like. I used clips of a popular YouTuber, Seth Sintach, and made the demonstrated directory structure to contain the audio files, which must be FLACs for this software to recognize out of the box. I recommend using a software called FlickFlac for converting files to FLAC format. It's free, easy to use, and I've linked it in the description for your benefit. Now register your dataset in the software by opening the Python file in the toolbox folder called init.py. Simply add the name of the directory following the style of the other existing datasets. Relaunching the toolbox with the adjusted command python demo toolbox.py-user audio. When relaunching, you should see that your dataset is now visible. It looks like it loaded with an error. Let's install that missing package real quick to get rid of it. There we go. Now it looks like we were all ready to go. Let's run through everything real quick and make sure it all works.
Like to order a pack of shit bricks, you can't. I'm going to be going into hiding for a week. My current roommate.
A special secret between you and me. You don't need to order ship bricks. You can make them on demand at any time you like. Now this is literally and figuratively exciting shit. Finally, let's see how it performs.
If you got this far, the rest should be pretty self-explanatory. I would like to state that the model is much more efficient. That is, it works way better with longer sentences. It might be counterintuitive, but just roll with it. While you can generate projections, you don't need to. Simply load the file you want to clone, select which embedding to use in the synthesization and vocoding, then click the Synthesize and Vocode button, and it will process your text and create the audio output. You can also train your own models to get an output that sounds more like the speaker you want to clone, but that will take a long time and is a topic for another video. I wish you the best of luck. If this video helped you out, please consider buying me a coffee donation. Link is in the description. Thank you.